Hello, thank you everyone for joining today. We're so excited to have Andrew DeMarco here today to speak for us, and they will be speaking on the topic of biomedical research. Currently, Dr. DeMarco is a um, professor at the um, University of Pittsburgh. And with that, I will hand it over to Dr. DeMarco to talk on biomedical research.
Okay, thank you so much, Ajali, for that lovely introduction. Um, so, full disclosure, I am a postdoc, which is sort of a professor when it's convenient for the university and sort of not a professor when it's convenient for the university. You can think of this position like a postdoc in training or a professor in training. And so, what I'm going to do today is talk to you guys about kind of what kind of give you some ideas. I'm sure most of you who are listening and are listening to YouTube on YouTube as well have some idea what biomedical science is, and then kind of lay out for you how to get involved, what are the options, and then kind of how I got from where I wanted or what I thought I wanted to do to where I am now, and then also a little bit about what kind of work I'm doing right now. So we're gonna try to cover a lot in a little bit of time. Um, Thank you to STEMI for having me. It's a pleasure to be here as well. Okay, so I think everybody um, could probably couldn't give maybe give a definition of biomedical research, but you would all know the products of it. So on the left-hand side, this is a representation of a drug that is beginning to a lot of people might recognize the ads for Humira. You might also recognize ads you've seen on television for Keytruda, and then the CAR T cells. These are all products from biomedical research where we have a disease we're trying to focus on, we're trying to understand the disease process, and then we're trying to work backwards to find a cure that we can give to people to try to make their lives better. So that's at least how I would give you what I would give you as a definition for biomedical research. Um, and biomedical science is sort of the same thing, right? Is the application of biology, life sciences, physics, and chemistry to better understand human disease and treatment options. So if that sounds like something you'd be interested in, great. So what do you need to do in college? What do you need to study? Well, any one of any sort of life science discipline, microbiology, chemistry, physics, biochemistry, neuroscience. A new and emerging field which is going to gain a lot of ground is specifically bioinformatics. That's taking uh, computer science and merging it with life sciences to create to help scientists understand the mathematical relationships between different molecules inside a cell and understand different processes in an organism. Um, and one advice I would give to you as you're touring colleges and as you're kind of thinking about what you want to do, if doing a biomedical research or research type career is of interest to you, ask about that institution's undergraduate research program because that's going to be the quickest way for you to get involved early and get some practical experience. And that will also catapult you into a one of two different career options. You can either get a PhD like I did or an MD. And having the undergraduate research experience helps set you up well for admission to either one of these different programs. So what do you want to, what do the admissions processes look like once you've gone through college and you're just trying to decide which one of these you want to do? Medical school is a 2-year process. I applied to full disclosure, I applied to both medical school and graduate school, and I got into both and talk a little bit about that later. But when you have medical school, you have two options. You have an MD or a DO, right? You're going to spend your first year of your junior year practicing for the MCAT, which is a medical school entrance exam, and then take it usually winter or spring of your junior year. Then during your senior year of college, you'll fill out the applications, the AMCAs for the MDs, the ACOMAs for the DOs. Then you'll do an interview. Sorry, you'll do a secondary application so that if they like your first application, they'll send you a second application to fill out, lucky you, and then do your interviews after that. That's typically all done during your senior year of college. And then you're going to go to medical school and you're going to have 3.5 years of training. then you're going to go to postgraduate training. Now, there's two types of ways that MDs get involved in biomedical research. The first of which is they're on the more clinical side, kind of helping during drug trials and taking care of patients so that the people who are on the research side and they collaborate with people on the research side to help us figure out what's working, what's not working, where can we improve. MDs can also be involved in leading benchtop research, although it's more common for PhDs to do that. You can also do an MD PhD, that's a dual degree, and that works by doing your first 2 years of your MD and then your PhD, then the last 2 years of your MD. I should also say that when you go to college, a lot of schools will have a medical school advisor program. And so when you're interviewing for colleges, talk to them and see kind of what their success rate is, what kind of services they offer, and they will be in a good position to try to help you get where you want to go. So get in touch with those folks early. Graduate school admissions is a little simpler. It's just a senior year of during college, you can apply to graduate school. You have you may or may not have to take a GRE depending on the school. Most schools don't require that. You'll do an application, then you'll do an interview, and then you typically for science programs, once you're accepted into their PhD program, the first 2 years of your program are spent doing your graduate courses and identifying your PhD mentor, and then you take this candidacy exam in year 3. During this third year, if you successfully pass the candidacy exam, you can matriculate on to complete your doctorate. If that's something you go through the first 2 years and you decide that maybe this isn't for me, then you can graduate with a master's. So applying to a graduate school program gives you one or two options to get an advanced degree. And just because you don't leave with a doctorate in philosophy doesn't mean you can't participate in biomedical research. You just won't be leading a team of scientists, you'll be part of the team. So, that's something to consider when you go in to apply to these programs, to think about, do I really want to be leading the research, or is it fun for me just to be involved in this and then kind of have more of my weekends back, essentially, is what it ultimately equates to. And like I said, the reason why undergraduate research is really important is because if you invest that time during your undergrad years in a lab, that PI, that mentor that you have, will be able to write a really strong letter of recommendation for you for graduate school as well as medical school. So those letters are really important. They're probably going to be some of your strongest letters, regardless of what path you choose to follow. So getting involved early in undergraduate research, really important for either path you take. So I'm a PhD, and I'm going to spend the rest of my time kind of talking about what you can do with that degree. Although if you have questions about what medical research or MD-based research looks like, I can certainly answer those as well, but I'm going to admittedly toot my own horn a bit. So what can you do with a PhD? So we're going to go back to front of things that are less common to more common. So let's say you go to your PhD and you spend your time in the lab because you're going to have to do that to get the degree. You come out of that and be like, I really like science and I'm interested in understanding, making it better and contributing that way, but I don't like bench work. So that's okay. You can get involved in consulting. So that's working in a private firm, giving advice to other groups about scientific problems, or working with Wall Street firms to advise investments. That's kind of a business and science interface, more on the consulting end. Then you can also work for the government. They have their own research labs. They also do a lot of consulting. You advise politicians, or if you really want to participate in some Tony Stark type research experiments, you can do, the military has their own research division. The DoD, the Army, the Air Force, they all have research programs, and you can get involved there as well if you're kind of interested in doing science, doing research, and also contributing to the safety of the country. Lastly, what most people do is kind of get involved in either education industry, and this is kind of the majority of scientists, where basically we're doing some sort of research. The difference between these two groups is what direction the research takes. So academic science, which is where I work in, it's a small business comprised of a bunch of different groups of people. The undergraduate researcher is where you guys would be coming in. You're training and you are learning basically how to do the fundamentals of science. You're working under the supervision of a PhD student or a postdoc, a senior person who's kind of helping you work on a part of their project to kind of answer a question that the PI is interested in. And the PI is effectively the CEO. They decide the research focus, they have a question that they're interested in solving, and the postdocs and the PhD students and the master's students are all working on pieces of this. Postdocs, so people who are in my position, they've completed their PhD, but they're doing additional training to become the PI. So they're kind of that middle management position. And master's students or graduate students are learning to be independent scientists. So postdocs are independent scientists with additional training. PhD and master's students are working to become independent, and the undergraduates are learning science fundamentals. The one thing I will stress is when we talk about undergraduate research, I do not mean, working as a lab technician, just cleaning glassware. You really want to find a position where the undergraduates are part of the research process. And so they typically will have a specific project that they're working on and a problem they're trying to solve, as opposed to kind of just doing, effectively maintenance work around the lab. Having actual experience working on a scientific problem is much, much more important, frankly, than, just spending time in the lab. Industrial science, or what I would really call the pharmaceutical industry, takes the other big piece of what we do as biomedical PhDs. They are working on developing therapies that I showed you at the very beginning, like Keytruda and all these things. And it's the same group of people, but they have all finished college, right? So they're all either bachelor's, master's, or PhD holders. PhDs are the ones that are sort of driving the research and submitting new ideas and pushing for new research, and the MS and the BS holders are supporting that. So that's kind of the three different ways. There are two ways you can get involved and kind of the options you have when you choose a degree. So how did I get here? Well, I had an expectation and I had a reality. So my expectation was I was going to go get my bachelor's in chemistry. Instead, I ended up getting my bachelor's in biochemistry. And then I wanted to go to Pittsburgh Medical School to be a doctor. Instead, what I ended up doing is go to a master's at Georgetown, get my PhD from Purdue, and then obviously I was going to go into postgraduate work in pathology, and I ended up going to University of Pittsburgh Medical School for my postdoc. So I kind of had a vision for being involved in biomedical research, but didn't take the route I had originally intended. And the primary reason for that is I didn't really like standardized testing, which is what you will get a handle on when you, I guess now for the SATs and then for MCATs. And medical school was a lot of test taking. That just wasn't my thing. So how did I get here more specifically? So I entered undergrad in 2013, and at the end of my sophomore, beginning of my junior year, I began MCAT prep and scored a below 508. So 508 is kind of the magical cutoff for when it's acceptable to apply to medical schools when you take the test. I didn't get a good score on the first time. I retook it in the summer. I had to take a gap year. That's pretty common for a lot of people. Most people now take gap years just to study for the MCAT. So don't think you have to matriculate straight from undergrad to medical school. In that gap year, I went to Georgetown and did my master's, and I retook the test and then reapplied to medical school and reapplied to PhD programs. And I got accepted to both and chose to get into my PhD at Purdue because I really enjoyed doing bench work. I liked working on biomedical science problems, but didn't necessarily enjoy a lot of the other aspects that go with medical school, mainly, as I mentioned, all the test taking. It just wasn't my thing. I'd had enough. So I went to Purdue in 2018. Your first 2 years, right, you pass your classes, and you take your candidacy exam in 2020. When you're interviewing for PhD programs, one thing I wish I knew to ask was, what do these candidacy exams look like? And I realized that's far away for most of the audience here, but it's never like when you go to your undergraduate program, ask the graduate students there what their candidacy exam is like. They'll give you some idea of the type of um, exam you're going to be asked to pass to go into to complete your doctorate. It's basically a independence exam. Can you think on your feet? Can you answer scientific questions and discuss science intelligently? Almost everyone passes this exam, so it's not as if that everybody, most people fail, but the way the exam is handled is different for every group. So be aware of that, or every graduate program. Um, I completed my PhD in 2023 and then went to University of Pittsburgh Medical Center, where I currently work on uh, psychiatric diseases. So I study the brains from patients who have passed away, who had a psychiatric disease like schizophrenia. And I try to understand how the brain has changed between when you have a healthy patient, when you have a patient with a psychiatric illness. So what are the fundamental differences that lead to these patients who have this disease? As I didn't know because I wasn't a neuroscientist when I got this job, but I had some idea, right? The brain is a series of interconnected circuits from a bunch of different cells, all working to do different things, and they all communicate with each other. The fundamental unit of each of these connections is a synapse comprised of a presynaptic and a postsynaptic terminal. These things come together, information is exchanged. However, in schizophrenia, which is one of the diseases I study, the postsynaptic end, as you can see here by these little blobs, they're called dendritic spines, but these little knobs here are the postsynaptic terminal here receives information from the presynaptic terminal. In schizophrenia, the schizophrenia patients don't have this postsynaptic terminal for whatever reason. So the underlying question I'm trying to answer is, okay, these patients have these loss of these dendritic spines. Why? What is the reason why the cell can no longer make these things and maintain them? And so how do we do that? We have basically take a global approach where we take data from multiple different levels of cellular biology. So things that are called metabolites, which are basically your cells. You take measurements of the cell's metabolism, the cell's protein levels, and the cell's genetics, and you integrate them together to come up with an idea of how all these things are moving to uh, make a dendritic spine, which is this thing, and then what happens to those systems in the schizophrenia condition when those spines are lost. So that's kind of a little bit about what I do. If you'd like to know more, here's my email. Happy to answer any questions you guys might have, or have any other questions about medical school or admissions or anything like that. This is my lab. Here I am. Here's my boss. Here's the members of our group. And with that, I'm happy to take any questions you guys may have.
Thank you so much, Dr. DeMarco. And I love seeing some of your research. It brings me back to my younger years. So thank you for that. Does anybody, Aria, do you have any questions? And sorry to put you on the spot, but just wanted to see, and if not, that's okay.
I don't really have any questions, but it was a really informative presentation. I didn't really know much, but now I do. So
Yeah,
thank you.
glad that was helpful. When you go to, like I said, when you go to tour your undergraduate institutions, ask about those things. That'll really, get a sense of, by asking those types of questions about undergraduate research and the support for, medical school admissions or graduate school admissions, they will direct you to the resources that you need there, and they'll be able to more directly help you.
Great advice. Okay, so I do have a question, which is, and thank you for telling us your story, because I think it's really great for people to hear the path of PhD versus MD, and you had the unique experience. It doesn't, even though I know you probably know a few people who've done that, but it is pretty rare in the realm of, the universe. It doesn't happen very often. There's not very many people who try to actually do both. And so I think it's good for people to kind of see the difference and ask that question of which one do I want to do. In your entire process, thinking about your career and where you are now, especially doing as a postdoc, what would you say you like about and what do you not like about it? Like like, I want you to kind of be real with the students. What is really hard about this process? What have you struggled with? But then what keeps you going? What do you love about it? What do you enjoy?
So what is science is intrinsically hard. I know you spend a lot of your time failing, not because you didn't do a good job, it's because you had the wrong answer. And that's not your fault necessarily, but we don't do a good job of teaching, I think, people how to fail gracefully and how to deal with that failure, right? And that's really the one thing that graduate school is going to teach you is that through no fault of your own, because life is complicated and because science is hard and because you can't just pull a cell out of the dish and go, what do you mean? You're going to struggle. And so that's kind of what's hard. But what keeps me going is actually, I have a picture that goes with this. Oh, not this picture. So schizophrenia is really interesting because it's sort of a loss of your ability to control your inner monologue, essentially, is how I would describe it. So these are a series of paintings done by a man,
they knew what they were doing.
By a man who was on antipsychotics and then came off of them. And he kept a journal as he went along. He basically lost the ability to control his perception of reality. He thought people were stealing his thoughts. People were, inside of his head. People were, persecuting him. They could hear everything and they were constantly mocking him. And this is happening to someone who otherwise would appear normal. These people need help. And there isn't the amount of energy we've put into solving cancer hasn't really gone into helping these people. And I think they could use our help because they're sort of stuck in a prison of their own mind and not of their own making, and they don't have the resources to help them. So, someone should.
Yeah, thank you. And thank you for talking about a disease that I think there's a lot of feeling of taboo and negativity around it. And it's really just a disease like any other and should be just, I think when people think of mental issues there's a lot of judgments tied to it. Oh, you have mental issues because you're bad, or you deserved it in some sort of way or something, when instead of, if somebody had a cold, they wouldn't say, oh, well, that's because you're a bad person. It would just be like, no, you have a cold, let's treat it. And I wish that a lot of especially schizophrenia and a lot of other mental disorders were treated as such.
Yeah. So one of the things that the University of Pittsburgh specializes in is we have the U.S. is not the world's largest collection of human postmortem brains, and what that really means is that the chair of our department, who's a gentleman by the name of Dr. Dave Lewis, he is actually the one who found this. This is his seminal finding when he was a researcher, and he's now the department head. We have a collection of these brains, so we treat the underlying hypothesis is the brain is an organ that's sick, just like we would think about a cancer cell in the same way. So we're trying to pursue that line instead of it being oh, this is just what happens. Like, no, there is an underlying mechanism here that we need to pull at because there's a very strong genetic component to schizophrenia that I didn't really talk about just because there's not time. So, and there's not just genetic factors, there's environmental factors, and all of these things are causing physical changes that we need to understand. And I guess speaking to the whole taboo thing, the biggest misconception about schizophrenia is that these people are violent. That's just not true.
Yeah.
That if they're going to harm anybody, they're going to harm themselves, and that was the case with this man. As he did his series of paintings, he eventually took his own life tragically. So there's a series of journal articles if you're interested in learning more at this website down here. all of these paintings and all of his thoughts as he was going through this experience are on there for you to look at and kind of appreciate.
Thank you, Andrew. Appreciate that. Tejasvi, did you have a question?
Yes. I was just wondering, what are your future goals?
So I have, in the immediate future, I am beginning the process from transitioning from a faculty in training to a faculty position here at Pitt. And then from there, I sort of begin to explore my own vision for how we might try to address this problem here and how we might help these people. So we have some ways of thinking about how information is transmitted throughout the cell and how that information infrastructure might change in the context of schizophrenia. And so if we can understand how that system changes, then we can maybe find the ways to reroute it basically in kind of a simple form to try to, basically try to reverse engineer this, right? So we could maybe get some more spines so there can be more effective cell-cell communication. So maybe we can help these people.
I have probably a couple more. So first off, what if a student knows for sure that they want to pursue this? What would be, biomedical research? And again, it may not be necessarily schizophrenia or neuroscience or neurology or any of those realms, but just biomedical research in general. What would be your advice to them? What could they do now in order to kind of set themselves up right?
This is like the junior,
Middle
like
school
juniors,
or students, yeah.
high
Probably
school.
closer to high school, but yeah. But
Um,
there are some middle schoolers who are very adamant that they want to pursue this field. I have met them before.
yeah, wow, that's impressive. So I didn't really know I wanted to do this until I ran into it. I knew I kind of always want to do biomedical research. I didn't necessarily know I wanted to do this. What do you do for high school? That's a really good question. I, so the high school, some universities offer high schoolers a chance to get involved in research, especially over the summer. There's a lot of these camps that are around in the summer that are basically research camps, for lack of a better term, where my former PI runs one in Indy or at Purdue, where they take high schoolers from junior or senior year who are interested in getting involved in biomedical research, and they do a 2 month research project under the supervision of university staff. And so it's basically like a camp. It's called, oh, geez, actually, I can look that up. It's got a very specific name. But they're, basically summer research, summer under high school summer research programs.
Yeah, usually I think a lot of colleges do offer, I'm sorry, there's
No,
a
it's
couple
okay.
that'll offer it, I think, too.
Yeah, there's oh yeah, so it's called the Summer Undergraduate Research Program. That's what it's called. Okay, so it doesn't have a fancy name. Um, but yeah, so I would look into programs like that. I'm sure Duquesne has one around here, or you guys are in Texas, right? So I bet UT has got some high school focused summer research programs. That'll give you a good sense of is this for me or not, and kind of getting involved.
Perfect. And what about, let's say I have two opposing questions, which is one, how, if a parent knows that their student is interested, do you have any specific advice to give to the parents on how to coach or guide your students or their children if they know they want to pursue this field?
Yeah, that's a really good question. So if you're a parent, so I'm not a parent, just for full disclosure. Um, I think um parents. You might have stumped me. I generally so the one thing that my parents did for me that I don't think that I give them enough credit for is allowing me to kind of go out and figure out on my own, just being supportive of my decisions, and then encouraging me to, you know, to not be like I was so focused on medical school, and they kind of like, well, don't get so zeroed in on one thing, be kind of open to different approaches. And so that's what they did for me. And to their credit, I think it's been very successful.
Mhm.
Um, you know, I think also um helping having a timeline. I think having helping kind of knowing where everything is, because that's something that I probably would do for myself now, but I didn't have the wherewithal to do that as a kid. And when you're getting ready to go to college, the last thing you're keeping track of is okay, where are the deadlines for these things? Where do I need to be to get myself ready for all of these different things? So that would be what I would suggest.
No, that's perfect. I think that's great. Yeah, especially the let your student decide or let your child decide. I think
Yeah.
um
Actually,
particularly
one more thing, if I may.
please.
Um, they don't need to go to like not everybody needs to go get the full doctorate. One of the things that you see is like there are these wonderful group of people in medical research labs who are the unsung heroes who just they come in, they love to do bench work, and then they go home and they don't have to, be leading the lab to make a meaningful contribution. And I think every parent wants their kid to be, on the front page of every magazine, I think, because that's how they feel about their kid. And that's wonderful. It's just, sometimes that's just not how that's not how things materialize, and that's okay too.
Yeah. Yeah, and sometimes people don't want that either. They don't want
Yeah,
to be the face of the lab
yeah,
or leading initiatives. They enjoy just knowing that what they're working on is just as critical as the person leading it. And they have just as critical part. I know tons of people who don't want to necessarily lead things, and they enjoy where they're at, and that's very important. That's very important. Their role is very important. Well, any other questions, Aria, to Jotsby? Anything to add? All right. Well, thank you so much for that. I really, and thank you for throwing in some of your research. It was, again, for me, really enjoyable to kind of like go back and you did a fabulous job of presenting it in a way that I hope everybody felt like they were able to absorb and understand, and take a look at. And then the resources as well that you provided for the students, to take a look at as well while you were talking about the different pathways that they can pursue. So
yeah.
thank you so much, Dr. DeMarco. Any last comments from you? But
Just the only other piece of career advice I would give you is as long as you're doing something that you love, you will never have a truly awful day at work.
very true. Yeah. We at STEMI are very much pursue your passion. I don't see these fields as a field where you should pursue it for money by any means. It's a tough field. They're both tough, whether you become a doctor or a PhD researcher. You don't want to do it for the money. You need to love it. You have to. And if you feel pressured into it, then I think you should very much question whether you want to do it. It takes a lot of grit. And you have to be okay with failure, as you mentioned. So it takes a lot. All right. Well, thank you so much, Dr. DeMarco, for everything. Greatly appreciate you having on. Thank you to everybody who joined, whether you're in the meeting in this presentation itself or whether you're watching on YouTube. And thank you to everybody for joining. Thank you, DeMarco. Take care. Bye-bye, everybody.
Bye.